So, angle 1 congruent to angle 2, reason given. Get into the habit of, after writing it, marking your picture. This one's already marked for us, but you can just trace over it. That angle 1 is congruent to angle 2. In order to prove the lines are parallel, I only have one way to do that, by showing corresponding angles congruent. Branson? Why would 2 and 3 be congruent? Okay, good. Sorry, I didn't mean to cut you off. Angle 2 is congruent to angle 3 because of the vertical angles theorem. Well, since 3 is congruent to 2, and 2 is congruent to 1, what does that tell us about 3 and 1? They got to be congruent, right? What would be our reasoning to get to that point? Substitution, good. 1 is congruent to 2, so we can substitute 1 in for 2. Looking at the diagram, how would you classify 1 and 3? Corresponding. If corresponding angles are congruent, then my lines must be what? Parallel. Are my corresponding angles congruent? Yeah, we just proved that. So step 4, M is parallel to N. Reason. If corresponding angles are congruent, then the lines are parallel. Sure, they looked like they were parallel, but we had to prove it by using our corresponding angles postulate. If the corresponding angles are congruent, then the lines are parallel. Okay, let's step back and look at this with a wider lens. Given to me, angle 1 is congruent to angle 2. What kind of angles are 1 and 2? Alternate interior. So we're basically saying, if the alternate interior angles are congruent, then what can you tell me about the lines? They're parallel. Look at the bottom, or right below this proof, there's a bunch of questions. What did you prove in number 1? What was given to you? What did you prove? Can you write a conditional statement? That's an if-then statement, using what you were given, what you were proved. Ready? Write this down right below all those italicized words. If alternate interior angles, AI angles, are congruent, then lines are parallel. If alternate interior angles are congruent, then your lines are parallel. That's a theorem to add to the 6 theorems we've already talked about. They're on the floor over there for some reason. Sorry about that. Because we just proved that theorem. That's one of our theorems that we just proved. I have it up here on this blue poster. If alternate interior angles are congruent, then your lines are parallel. Okay? Postulates, we didn't have to prove it, so we were able just to use it. Now, since we proved it, we can use it. Okay? Okay, let's go to the second proof. Given 4 and 5 are supplementary, we want to prove that G and H are parallel. Let's just get this given in here. Angle 4 and angle 5 are supplementary. We want to prove the lines are parallel. You have 2 ways to do this now. You have the postulate at the top. If corresponding angles are congruent, then the lines are parallel. Or you have the theorem you just proved. If alternate interior angles are congruent, then the lines are parallel. Look at the diagram. I've labeled 3 angles, 4, 5, and 6. Those are the only ones we're going to work with. Can you classify any pairs of corresponding or alternate interior angles between 4, 5, and 6? I'm either looking for corresponding or alternate interior, because those are the only 2 that can prove lines parallel. Or what? Yeah, 6 and 4 are alternate interior. I think you said 4 and 5. If we can prove that 6 and 4 are congruent, then the lines are going to be parallel. because we just used that theorem. If alternate interior angles are congruent, then the lines are parallel. So we're trying to show that angle 6 is the same as angle 4. Well, we already know in our given that 4 and 5 are supplementary. What does it mean if they're supplementary? They add up to 180. Let's just rewrite that as an equation then. The measure of angle 4 plus the measure of angle 5 equals 180. And that would be by the definition of supplementary angles. What does it mean to be supplementary? Add up to 180. Again, we're trying to show that 4 and 6 are congruent, because if alternate interior angles are congruent, then the lines are parallel. So I need to get something in my proof in the statements about angle 6. Why would 6 and 5 be supplementary? Good. Measure of angle 5 plus the measure of angle 6 equals 180. That would be our angle addition postulate. They form a straight line. They're adjacent angles that form a straight line, so if I add their measures up, I get 180. So we have 4 and 6 in the proof, and we're really trying to show that they're congruent, because if they're congruent, then my lines have to be parallel. Well, I have two equations. Angle 4 plus angle 5 equals 180, and then angle 5 plus angle 6 equals 180. If I have two angles equal to 180, or excuse me, two equations equal to 180, what can I do with them then? Good, set them equal to each other. Measure of angle 4 plus the measure of angle 5 equals the measure of angle 5 plus the measure of angle 6. What's our reasoning for that one? Yep, you can use transitive or what? Or substitution, whichever one makes more sense to you there. We're trying to get 4 to be the same as 6, equal, congruent. We're really close. We got 4 equals 6, but these 5s are in the way. I'm going to get rid of those 5s. Subtract them, good. When I subtract the measure of angle 5 from both sides, they end up canceling out, and I get the measure of angle 4 equals the measure of angle 6. When two angles are equal, we can also say they're what to each other? Congruent, okay? So what we just did in 5 steps was show that angle 4 is congruent to angle 6. And what types of angles are they? And if alternate interior angles are congruent, then what do we know about these two lines? They're parallel. Number 6 is your last one. G is parallel to H. Reasoning. If alternate interior angles are congruent, then the lines are parallel. Zoom out, look at it from a bigger perspective. Given, if 4 and 5 are supplementary, what type of angles are 4 and 5? Same side interior. So instead of saying 4 and 5, we could just say if same side interior angles are supplementary, then the lines are what? Parallel. There's another theorem. That's this fourth one I have right here. If same side interior angles are supplementary, then your lines are parallel. Okay. The top 5 are what we're going to talk about today. Go ahead and flip your paper over. You should have 5 bolded rules, postulates, and theorems there. The first one, if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. You proved those 2 theorems in class. The last 2, if alternate exterior are congruent, lines are parallel. And the last one says if same side exterior are supplementary, then the lines are parallel. Those are 5 ways to prove lines parallel. You have to know them. I have them up here on this blue poster. That blue poster won't always be there. You know how you have them all listed there? Make one of these things to the left of them in the margin or whatever, something to bracket them off. And write ways to prove lines parallel. Those are 5 ways to prove lines parallel. You will learn 7 by the end of the week, but we have 5 today, and again, they're up here on this blue poster. They're the converse of last week's theorems. That's why last week I made you write, if lines parallel, then alternate interior angles are congruent. Because this week, you have to write, if alternate interior angles are congruent, then the lines are parallel. You have to know what you know. Are the lines parallel or not? What are you trying to prove? At the bottom of this page, you should have a bullet of 6 and then a bullet of 7. The 7 says ways to prove lines parallel. We're not going to fill that out because you have 5 of them listed above. But we are going to list the 6 properties of parallel lines. Properties of parallel lines are when the lines are parallel. So when the lines are parallel, corresponding angles are congruent. Maybe you want to do this. This is what I would do as a short note taker. When lines are parallel, then corresponding angles are congruent. Then you don't have to repeat when lines are parallel 6 times. You just have to write it once. And you can just put the conclusion under your numbers. So when the lines are parallel, your corresponding angles are congruent. Your second bullet, when the lines are parallel, alternate interior angles are congruent. So for number 2, when lines are parallel, then alternate interior angles are congruent. This is when they tell you they're parallel, then you know this is true. If 2 lines are parallel, then I know that the alternate exterior angles must be congruent. When they say the 2 lines are parallel, then we know that the same side interior angles have to be supplementary. When the 2 lines are parallel, and we know that the same side exterior angles are supplementary. Those are the properties of parallel lines. If the lines, those 2 lines aren't parallel, then those things don't have to be true. It's just when the lines are parallel. Your 6th property says that if a transversal is perpendicular to one of 2 parallel lines, then it's got to be perpendicular to the other one. I don't have shorthand for that. You're just going to have to write that one down on number 6. If a transversal is perpendicular to one of 2 parallel lines, then it needs to be perpendicular to the other one. Just think of these, I don't know, buttons that I have up here, the blue ones and the green one. Would you say these are parallel buttons, parallel lines? Okay, so if I draw a line through them so that the red line is perpendicular to the green one, it's got to be perpendicular to the other 2. Because when the lines are parallel, corresponding angles are congruent. So if this one's 90, then this one has to be 90, making it perpendicular. Think of your ceiling tiles, the dividers. All the ones that are running north to south are parallel to each other. This one going east to west is perpendicular to that one. Well, it's got to be perpendicular to all of them because they're parallel, because corresponding angles are congruent. So if you have a transversal that's perpendicular to one parallel line, it's got to be perpendicular to all the parallel lines. Okay, those are 6 ways, or 6 properties of parallel lines. We're going to use the 5 ways to prove lines parallel today. So go ahead and flip it over. And number 1, you should have a diagram with 4 lines there. Okay, 1 part A. Which lines, if any, must be parallel if angle 3 and 2 are supplementary? Like last week, you have to start by finding the angles, finding their transversals. Here's 3, here's 2. Which of my 4 lines there would be the transversal for those 2 angles? They're all labeled. CK, right? The CK, E, and D, those are the points of intersection. So I can call this line CK. So there's my transversal. The two lines that help form the angles. Good. EC forms angle 3 with the transversal, and DK forms angle 2. Once you figure this out, you have to classify them as one of our 5. How would you classify 3 and 2? Same side exterior. And the theorem today says if same side exterior angles are supplementary, then the lines are parallel. Well, what do they tell us about 3 and 2 in this information? They're supplementary. So since they're supplementary, these two yellow lines have to be parallel. So which lines, if any? Line EC is parallel to line DK. Those two are parallel because the same side exterior angles are supplementary. B, which lines, if any, must be parallel? Angle 1 is congruent to angle 2. Find the transversal first. DK, good. DK is the line that hits both of them. Then you have to, find the two lines that help form them. So angle 1 is formed by the transversal in ED, and angle 2 is formed by the transversal in CK. Brady, how would you classify angle 1 and 2 based off that information then? Good. And the theorem says that if alternate interior angles are congruent, then the lines are parallel, right? Do they tell us 1 and 2 are congruent? Yeah, they do there in the question part. Okay, so which two lines, Brady, have to be parallel? Good. ED and CK, the two that I have highlighted in yellow. Which lines, if any? ED is parallel to CK. Why? Because the alternate interior angles are congruent. Third one. Which lines, if any, must be parallel if angle 1 and 4 are supplementary? Well, there's 1 and 4. Maddie, which line is their transversal? Which line hits both 1 and 4 at the same time? Good, DK. Then ED helps form angle 1 with the transversal, and CK helps form angle 4 with the transversal. Paige, how would you classify angle 1 and 4 then as one of these 5 corresponding alternate same sides? Okay, they're inside of the yellow lines. Are they on alternate sides of the green one or same side? Aren't they both above it? Yeah, so instead of alternate interior, they would be good, same side interior. The theorem says that if same side interior angles are supplementary, then the lines are parallel. Well, we're saying they're same side interior, and this is saying they're supplementary. So Paige, would these yellow lines be parallel then? Yes, they would. So which lines, if any? We would say ED is parallel to CK. Yes, yep, for sure. Okay, 2 more in this diagram. D, which lines, if any, must be parallel if angle 3 is congruent to angle 4? Kylie, which line would be the transversal for 3 and 4? Good, line CK. This right line is hitting both angles. The two lines that form the angles then. 3 is formed by the transversal and EC, and 4 is formed by the transversal and DK. JC, how would you classify angle 3 and 4 based on this information then? Same side, because they're both to the left of the green line, right? Interior, are they both between the yellow lines? Okay. Good, these are corresponding angles. They're both in that top left corner of the intersection. Postulate says, if corresponding angles are congruent, then the lines are parallel. Clean. Are the corresponding angles congruent? So are my lines parallel? Yeah, and it's the ones I have highlighted in yellow. So we would say line EC is parallel to line DK. Classify the angles based off of the transversal in the two lines, and then check if it follows one of the rules. Last one in this section. Which lines, if any, must be parallel if angle 2 and 4 are supplementary? Which line is going to be the transversal for these two angles? DK? Couldn't DK be a transversal? Because it also hits both of them? There are no parallel lines. I can't classify these two angles. If I have two transversals, then I'm not going to be able to classify them. If I don't have any transversals, I'm not going to be able to classify them. If you can't classify them, then there's no way to tell if any lines are parallel. So which lines, if any? None. No transversal means no classification. No classification, can't tell me if the lines are parallel. Okay, next one, an algebraic type 1. Find the value of x for which L is parallel to M. So we're trying to find the value of x that would make those lines parallel. Well, before I can do that, I got to figure out what angles they're talking about. 14 plus 3x is this guy. 5x minus 66 is that one. Dawson, how would you classify those two angles that I marked with the blue? Good. And Dawson, if I want my lines to be parallel, then I need my alternate interior angles to be what? Congruent. So Dawson, what would I do with these expressions so that I could get, good, set them equal to each other? They're alternate interior, which means they need to be congruent if we want those lines to be parallel. So set them equal to each other. This is going to give us the x value that makes the angles equal. Subtract 3x. 14 equals 2x minus 66. Add 66 and you get 80 equals 2x. Divide by 2 and x is equal to 40. Double check. If I substitute 40 back in, what's 3 times 40? 120 plus 14. Okay, substitute it into the other one. What's 5 times 40? 200 minus 66. 134. Bless you. Is my x value, bless you, make them congruent? Yeah, so are my lines parallel now? Yes. So x has to equal 40 to make those lines parallel. 3, kind of like number 1. In the diagram, which lines, if any, must be parallel if angle 3 is congruent to angle 4? Here's 3. Here's 4. Start like you started the first one. Veronica, which line has to be the transversal? D, good, because D hits both 3 and 4. The other line that helps form angle 3 is line A, and the other line that helps form angle 4 is line B. So ignore everything else and just look at what we have highlighted up here. Mason, how would you classify 3 and 4 out of these 5 here? Are they on the same side of the transversal, or are they on alternate sides? Alternate. Are they inside of the yellow lines or on the outside? Inside, so what do we call those guys? Alternate interior. And the theorem says that if alternate interior angles are congruent, then the lines are parallel. Well, are those angles congruent, 3 and 4? Yeah, that's what they tell me, if 3 is congruent to 4. So which two lines have to be parallel then? A and B, the ones I have highlighted. Which lines, if any, are parallel? A is parallel to B. Explain. If alternate interior angles are congruent, then lines are parallel. Okay. Another algebraic one. Find the value of x for which A is parallel to B. Explain how you can check your answer. So first you have to figure out how are we going to classify these angles. What do you think, Wagley? Why do you want to make them supplementary? What do you mean, what's it? Good. Classify these as same side interior angles. They're on the same side of the transversal, inside of the two lines. Rule says that if same side interior angles are supplementary, then your lines are parallel. So we need to make these supplementary. 7x minus 8 plus 62. Negative 8 plus 62. 52, 54. Any takers? Yeah, okay. Subtract 54 to the right side. 126. Divide by 7. 18. Okay. How can we check that this is the correct answer? Substitute it back in. 18 times 7 is 126 minus 8. 126 minus 8, 118. How is that going to tell me if we're correct or not, though? Good. Add 118 and 62 and make sure they add up to what? 180, and they do. So then x equals 18. Okay. A rectangular wooden frame has a diagonal metal brace. So my rectangle here, it's like a picture frame, and then I have a metal brace going through it. The angles indicated were measured to be equal. The ones that are marked. Congruent, they're equal. Which sides of the frame are parallel if these two angles are congruent? Why? Explain. Good. DB would be the transversal, so they're on alternate sides of that. And then you have to figure out the other two lines. Well, this top angle is using line AB, and the bottom angle is using line DC. So when I classify them, they're alternate interior. If alternate interior angles are congruent, then the lines are parallel. The ones that are parallel are the ones that you highlight. So we'll say AB is parallel to DC. Explain. That should not be a question mark. That should be a period. Explain. If alternate interior angles are congruent, then lines are parallel. Okay, try these next ones on your own. A through E. Okay, so using the information, we have to decide which lines, if any, would be parallel. Part A, they're saying angle 6 is congruent to angle 3. Which line is their transversal? B, good, because it's a line that hits both of them. M helps make angle 6, and N helps make angle 3. Once you have that identified, then you need to classify them as one of your 5. Riley Larson, how would you classify angle 6 and angle 3 as one of these 5? Okay, are they your corresponding? Are they alternates, or are they same sides? 6 and 3, the ones I have marked in blue. Good, and the rule says that if corresponding angles are congruent, Riley, then the lines are what? Which lines have to be parallel in this case? Louder, I didn't hear. M and N. So you should say M is parallel to N. Explain with a theorem or a postulate. If corresponding angles are congruent, then your lines are parallel. B, 1 and 4 are supplementary. Oops, wrong color, whatever. Which line, A, B, M, or N, would have to be the transversal for 1 and 4? M, that's the one that hits both of them. 4 uses line B, 1 uses line A. Jacob, how would you classify angle 1 and 4? And if they're supplementary, then the lines have to be what? Which two lines? Good. A is parallel to B. If same side interior angles are supplementary, then your lines are parallel. Last part of this directions. 2 congruent to 4. Which line is their transversal? They don't have one, so can you classify them? So then can you tell me if any lines are parallel? No, so this would be none. There's no transversal, then you can't classify it as these 5. If you can't classify it, how are you going to tell me which lines are parallel? Okay, next 2, algebraic. They tell me something about the measure of angle 1. They tell me something about the measure of angle 2 and the measure of angle 6. I'm just going to put little curves in there because I can't fit all the expressions in there. Part D, find the value of x for which A is parallel to B. So we want to make A parallel to B. Sydney, that means M or N have to be the transversal. Sid, would you want to use M as in monkey or N as in nickel? Well, we're just trying to prove these two lines parallel. So I have to do something with those 3 angles to prove them parallel, to find the value of x that makes them parallel. M as in monkey. Why not the other one? Because it's only touching how many angles? N? Right, so is that going to give me, I can't write an equation with one angle. Yeah, so you want to use line M as your transversal. Dylan, how would you classify 6 and 1? Yeah, and if they're alternate interior, then we want them to be what? So what should I do with the expressions? Send them equal. Angle 6 is x plus 58. Angle 1 is 3x plus 10. I'm going to subtract x and 10 in the same spot because I don't have a lot of room. So you get 48 equals 2x. Divide by 2, and what do you get for x? 24. Anybody check it? Did it work? Cool. Great, and then our last one. Find the value of x for which M and N are parallel. I still know stuff about 1, 2, and 6, but I want M and N to be parallel. Emily, should I use line B as the transversal to write an equation, or should I use line A? Line A, because it has 2 angles that are hitting it. JC, how would you classify those 2 angles that are hitting it? These guys. Same side interior. They're both on the same side of the green line and inside of the yellow ones. Kylie, if they're same side interior, do we want them to be congruent or supplementary? Which means they have to add up to. Good. So angle 1, 3x plus 10, plus angle 2, 3x plus 14, needs to equal 180. Combine like terms. 6x plus 24 equals 180. Subtract 24. 156. Divide by 6, and what do we get for x? 26. Did you check it? And it worked? Excellent. Questions? Okay, I went through all the notes today so that we don't have to go through any tomorrow, which means more work time in class tomorrow, not necessarily today. Here's your homework for tonight, page 137, 1 through 21. And you have 7 minutes to get started on it now. You have 2 minutes to get started on it right now. Sorry, I was looking at the wrong one.